Today we are going to move on into solving equations with variables on both sides. So we start off with our first example, which says that we are going to solve 3n plus 2 equal to negative 2n plus 8. So step one of my process asks me to simplify each side of the equation. Well, in our particular case, 3n plus 2 and negative 2n minus 8 are both already simplified, seeing as how we cannot combine like terms. So moving on to step two says to get the variable terms together on the same side of the equation. Now, it isn't critical that you have a correct side and an incorrect side for which to move the variable terms to. However, there is usually a better side. For example, if I said, let's move 3n over to this side, to undo 3n, we would need to subtract 3n, which then if we subtracted 3n over here, we would get negative 5n. We have a negative variable term, so I'm thinking that we would have a better option if we went the other direction, simply because then we can keep our variable terms positive. So I'm going to choose to take this negative 2n and move it over here. Now to do that, that means I'm going to get rid of a negative 2n, which is adding 2n, and I'm going to add 2n by the golden rule to both sides. That will cancel these two n's, leaving me with negative 8. And on the other side, I get 3n plus 2n, which is 5n, plus 2 equal to that negative 8. So now we're back to a type of equation that you're familiar with. So then we are going to go ahead and follow steps 3 and 4, which are to use the order of operations backwards, which you've seen this before, to determine which operation to undo first, and then use the golden rule of algebra to cancel that operation. So if I go back and think about my process for building this equation 5n plus 2 equals negative 8, first I would multiply 5 on both sides to get 5n equals whatever our variable is times 5 to get negative, and then we would add 2, which would then end up resulting in our final equation. So if I make my U-turn, I'm going to end up with undoing plus 2 by subtracting 2, and undoing multiplying by 5 by dividing by 5. So if I go ahead and do this, I'm going to subtract 2 from both sides, which is going to result in canceling the 2's, leaving me with 5n on the left. And on the right, a lot of you want to take negative 8 minus 2 and get negative 6. However, if you recall, minus is the same thing as adding the opposite. So we actually have negative 8 plus negative 2, which is negative 10. So then our next step, we said we're going to divide by 5. So I'm going to divide by 5 on both sides. So when I divide by 5 on both sides, the 5's cancel, leaving me with n is equal to negative 2, because a negative divided by a positive is negative. So if I go back up to the top and I put my negative 2 in for the here as well as here, 3 times negative 2 is negative 6, plus 2 is negative 4. Negative 2 times negative 2 is positive 4, minus 8 is negative 4. So my equation ends up being correct. So to summarize, we first start by simplifying each side of the equation, then we get the variable terms together on the same side, then we use order of operations backwards, and use the golden rule to cancel the operation, and finally we repeat steps 3 and 4 as we need them in order to get us to our point of being able to solve our problem. So if we move on to the next problem that we have, I'm going to go ahead and put a window shade in here so we have some workspace without having to look at 2 of them. We have solving 8y minus 7 equal to 7y minus 2. So we've already simplified on both sides. So we're going to start, and I look at this as I can subtract 8y or I can subtract 7y. Remember, just because there's minus signs doesn't mean we're going to add, because these are both positive. I'm going to choose to subtract 7y from both sides because that's going to keep our variable terms positive. That cancels the 7y's, leaving us with -2. And then on the other side, we have 8y minus 7y, which is y minus 7. Then if I look at this one's pretty easy because it's a one-step equation. I'm going to undo minus 7 by adding 7 to both sides. Canceling here, giving me y is equal to -2 plus 7, which is positive 5. Now if I check this, 8 times 5 is 40, minus 7 is 33, and 7 times 5 is 35, minus 2 is 33, so we do check out. Then if we look at this next example, solve -12 plus 5k equals 15 minus 4k. So I'm going to choose to add 4k to both sides because that is surely going to get me a positive variable term, giving me -12 plus 9k equal to 15. Now if I were building this equation, I would multiply by 9 and then add a -12 or subtract 12. So when I undo, I'm going to end up adding positive 12 and dividing by 9. So I'll go ahead and do that. Plus 12 on both sides, giving me 9k on the left, and 15 plus 12, which is 27 on the right. Then I will divide by 9 on both sides, canceling my 9's, giving me k is equal to 27 divided by 9, which is 3. And if I check that, 5 times 3 is 15, -12 plus 15 gives me 3, and then 3 times 4 is 12, 15 minus 12 is 3. So therefore, the equation works out. We will continue with this work in the next video.